Okay, so here's the new frame that I designed. I wanted to do this video to show you the various design points and as to why I did them for this frame. So this frame is about as is 135 grams with the camera and the flight controller. Just the carbon fiber is 96 grams. So it's fairly lightweight, not necessarily designed for a racer, but an all-around quad where you can use for freestyle and you can also race with as well. So point number one is centralized weight. So what I wanted to do is instead of an H frame where the weight is distributed alongside, I wanted everything to be centered in the middle. And I think I've accomplished that. Holding this type of frame versus an H frame, you can really feel the difference um, with the battery in the middle, the bottom, all the electronics in the middle, and the HD cam on top. So I think that'll really help with the flight characteristics, the having everything in the middle. It'll fly a little bit better. Also, having not an H frame is going to help with the drag factor. So when the wind, you don't have as much wind um, hitting the frame when you're going. So that was point number one. Point number two, I wanted to have a frame that you can easily build. So there's enough room to build things on compared to the really tight racing frames that are X and just everything stacked. I tried to build them. I don't personally like to build those. I like to have a little bit more room. So I definitely wanted to do that with this one. And here you can see there's a lot of room to be stacking stuff on top, enough room for the camera, and on top, below the HD cam, there's actually more room there where you can put a video transmitter and even access the buttons and that kind of stuff. So there's good enough space to build, but not too much wasted space. Next thing is the FPV cam in the front. So compared to the H frames, I really wanted something that was a little bit more protected in every angle that you tilted the cam in. And that came the side plates. So here we have the side protected plates, so we can tilt the camera all the way up, and you can see it's protected by the sides. There's a little bit more room. So I tested on an earlier prototype with a 2.5 millimeter lens, and I have no issues seeing the sides. I've tried a 2.1 millimeter lens. You can barely see, I think, the sides, but I think that should be fine. But what is important is that it's all protected. Another thing in these types of frames is that tilting the camera, sometimes you can only tilt it so much and you hit the electronics in the middle. I did it in a way where if you mount it here, you can tilt it as much and it doesn't even touch the center stack. So I'm not sure if you're going to be able to see this, but for the cam, I could tilt it all the way up, like 90 degrees up. And then, here we go, I could tilt it all the way down, and it doesn't touch the electronics at all. So you're not restricted in the height of your mid-stack as to how low it needs to be. You can have lots of room there. As you can see, I build them pretty high in this one. This is the Brain FPV. Even below the PDB, I put in a lot of room there. The reason for that is that I break a lot of battery straps, and I want to be able to just remove it, put one back in without taking anything apart. So I put in a lot of room so it's easy to put in there. So that's for the FPV cam, lots of room. You can mount, this is an HS1177 camera. The arrows can also fit on there. That's the other two little mounts on there. As you can, the screw holes, you can use those two screws to mount. And I think for the arrow, you can go up to 70 degrees, I think, up. So lots of room you can tilt. I wanted to be able to carry an HD camera easily. So for the side plates, this is a 45 degree angle. I have also a 30-degree angle as well that you can put on, or whatever else angle you want. But I kind of like 45 degrees lately. This is my Yi. You can just put it on there. And, you know, it's all built in. So the way I usually do with the Yi, I just put a zip tie going around and around this this standoff around here, and I just zip it around. So you can also have a slot here for a strap that you can go around, say for a session, a GoPro session or something, or any other type of cube HD cam. You can just put the strap on top around there, and you can put it tied. So everything's built in for that. So that was important. I wanted to be able to record in HD for myself. Point number 5 is the video transmitter mount needs to be mounted to the back. So here I have a little plate where you can mount your antenna and VTX on, and so it comes out of the back. So I think I have, here's my other prototype frame here. You can see it comes out from the back. So I thought that was important. I had the antennas going at the top, and I just didn't like that. In a crash, there's more chance of breaking. The other one, it just goes down. So, and for this mount plate, you can actually have it here, or you can have it actually lower. So there's actually tabs here, so you can move that down here. Point number 6 is that I wanted to have a perfect X motor position for the frame. So this is a perfect X frame, and it is at 220 millimeter in size. And the last point is that I wanted to make it tough. I wanted to be durable, and it could stand to crashes and that kind of stuff. And I think I've accomplished this with 4 millimeter bottom plates, 2 millimeter side plates, and how it holds down. There's tabs for the side plates here and here, and these go in, and then I have it's kind of another plate right here that goes into the side plates. So they go into the side plates here, and then that holds it down with a standoff at 30 millimeter height, and you can just screw it down. So it pushes down and holds the plates down, and these standoffs hold it so it doesn't move. And this is like, you know, rock solid. So that's basically all the features of this frame. Right now, I'm thinking of calling it the Griffin as the name of this frame. So, all right. So that's all. I hope you like it.